हेलो प्लेसमेंट का बादशाह. Okay, now today, so in the previous sessions we have covered the traversal part, we have covered validating the binary tree and the recovering the binary tree part. Now okay, so there is a question in the lead code which is asking us to find if the tree is same, so that is if it is a same tree or like that they are asking. So now let us see what is the thing what they are asking. So I am going to explain you it in a very easy manner. Suppose here the root node is present, okay, and then here the left subtree is present and here the right subtree is present. If the left subtree and the right subtree are exactly the same, what is the meaning of that one? So the left subtree's left child and the right subtree's right child is exactly the same, and left subtree's right child and right subtree's right child is exactly the same. In that particular situation we can call that tree as a same tree according to the question which is asked by the lead code. Now I am going to draw an example of the same tree. So here 1 is present and here 2 is present, and when we compare level wise, the right subtree must also contain the element 2, and then 2's left child be 3 and 2's right child be 4 and 3's right child be 5. This 2 must also contain the left child as 3 and it must also contain the right child as 4, and 5 must be the right child of 5. So if you see this, you can find that this entire left subtree and this entire right subtree is exactly the same. In this situation we can call this tree as the same tree. So is the question clear? Now I am going to explain a few things. So first I am going to tell some of the assumptions what we will make before solving the question. Suppose if the root what they will give, that means if the tree what they will give is null. If the tree is null, in this situation we can consider this tree to be a same tree. Okay, so this is cleared. This is one thing. And the other thing, suppose if they will give the root node and if the root's left subtree is null and root's right subtree is null, in this situation also this tree is considered to be the same tree, and each and every element which is present in this particular trees, that is the left subtree and right subtree, must be same. Now let us come to the coding part. So let us understand how can we code this particular solution. Okay, so I have mistaken the question. Okay, so just a second. So here I have explained for the left and the right subtree. So you can do this particular method just by removing this particular element, that is the root node. So I am going to remove the root element now. If I remove the root element, you can find that this is one tree. Okay, this is one tree and this is another tree. If these trees have exactly the same elements, that means each and every element present in this particular tree is same, in that situation they are considered to be the same tree. So initially I said that only one tree is given, we have to compare the left subtree with right subtree, but in the question they have asked, they have said they will give two trees and you have to compare whether the trees are same or not. Now let us come to the solution. Suppose if the P is equivalent to null, so this is the recursive solution what I am writing, and Q is equal to null. That means both the subtree what they have given is null, then I am going to return true. Okay, if P is equivalent to null or Q is equivalent to null. In this situation I have to return false, because in what this condition suggests us, so this is saying that this is saying that, one second, okay, so what they have mentioned in the question, okay, so what is the first condition suggesting us? Both the, okay, so the tree P is also null and the tree Q is also null. In this situation I am going to return true, because both the null trees are considered to be the same trees. Suppose if one tree has element 1 and other tree is null, in this situation I must return false, because a empty tree cannot be same as the non-empty tree. So this is the condition, okay, so what we are using. And also if these two conditions are not satisfied and the elements are present in the tree, like 1, 2 and okay, so 2, like that, the elements are present, then I must compare the value of each and every node. So hence, if P's value is same as, or I have to use not equal to Q's value, in this situation I am going to return false. Means if the P's value, if the node P's value is not same as the Q's value, then those two trees cannot be considered as the same tree. After doing all these things, I am going to consider the bool left. This is going to, okay, find the answer of the left, okay, so subtree what they have given, and okay, left subtree of each, okay, so this bool left is going to compute the left part of the P and left subtree of Q. So what I am saying, so if this is the, okay, so left subtree, and so this is the right subtree, so this is the right subtree here. So this bool left is going to find whether the left part of the subtree P and the left part of the, okay, tree Q are same or not. Okay, so in order to do that, I am going to call this function recursively, and I'll pass P's left child here, that means left subtree, and Q's left subtree. In the same way, I am going to find whether the right subtrees are exactly the same. I'll pass P's right and Q's right here, and if the left subtree is also same and right subtree is also same and P's value and Q's value are exactly the same, in that situation I am going to return true, that is left and right. So in this is the solution. So let us run the code and let us see how this works. Okay, so it is not value, it is just val. Okay, yeah, it's giving the answer correctly, so our solution is correct. Let us submit the code and let us check whether our solution is correct or not. Yeah, our solution is correct, and it's 100% faster when compared to the code which is written by others. But don't focus on these timings, just know how to code and analyze why are you calling those recursive functions and all. Thanks a lot.